Hello everyone, I'm Harriet Rinda from SRM Institute of Science and Technology. In the previous videos, we studied about the basic concept of backtracking and its application. So in this video, we are just going to study about another one problem solving technique that is called as branch and bound technique and an application assignment problem. Okay. So branch and bound technique is designed to solve the optimization problem only. What is the main goal of this branch and bound technique is we have to find the best solution among a finite set of solutions. We are having a lot of solutions, but among the various solutions, what is our concept is we have to find a best solution. That is the main goal of the branch and bound technique. So unlike backtracking, backtracking is mainly for a decision problem, but branch and bound, one main concept that is used in this branch and bound technique is nothing but it is a bounding function. What is this bounding function is? It's mainly used to get the best solution. So what are the solution that is not yielding a better solution means that is all discarded using this bounding solution. So normally optimization solution we are having minimization problem as well as the maximization problem. So for the minimization problem we are going to use the lower bound function, and for the maximization problem we are just going to use the upper bound function. So, but there is some major difference between the backtracking as well as the branch and bound technique. One such difference is backtracking is normally used to solve decision problems only. We are just going to find a set of solutions. But normally branch and bound technique is mainly is used for solving an optimization problem, that is it's used to find a better solution. Backtracking, we are just having search for all the feasible solution, but here in branch and bound we are just going to search for an optimal solution, that is the best solution. Then here in backtracking it prunes a branch when it violates a constraint. So here it nothing but it proves a branch that we are just going to indicate a bound function. So only for getting a best solution only we are just going to do this one. In backtracking we are just going to use a depth first search, that is DFS is used here. But in the case of branch and bound we are just going to use breadth first search, or sometimes we are just going to use DFS also. Backtracking always it does not maintain a best solution value, but in branch and bound technique we are just going to maintain a best solution, that is for the minimization problem or it is a maximization problem. uh, Basically in a branch and bound it is based on the upper as well as the lower bound, that is a cost function we are just going to use here. What is regarding the memory usage? Memory usage is generally low when we are just going to use the backtracking technique. And in branch and bound technique, it is little bit higher because we are just going to store multiple live loads may be stored there. So these are some of the difference between the backtracking as well as the branch and bound technique. In branch and bound technique, we are having three different sections. One is branching, bounding, and another one is the pruning. What is branching means? We are just, if you are having a problem, means that particular problem that is divided into smaller sub-problems. That is the one thing we are just going to do here in the branching state. Bounding means on if you are having any sub-problems means for each and every sub-problem, we have to go for a cost estimation. That is a bounding function we are just going to use. So bounding function means if it is a minimization function, we are just going to use a lower bound function we are using. If it is a maximization means we are just going to use an upper bound function. Next one, pruning means, what is pruning means? We are just going to discard the branches that cannot produce the better solution. If we are just going to decide, so that is one simple example. I'm just having 4 subproblem. We are having cost estimate. We are just going to select a subproblem which is having a less cost estimate. That is, other branches are discarded. So, which particular branch it is producing a better solution, we are just going to see according to the cost function. We are just going to travel with that one. We are just going to explore that one. Applications means we are just having 4 different types of application here. We can use branch and bound technique for traveling salesman problem, 0-1 knapsack problem, assignment problem, as well as the job scheduling problem. But in this lecture, we are just going to see one application that is called as an assignment problem here. I think all of you know about what is an assignment problem. Assignment problem is nothing but we are having n people with n jobs. So that is the concept is like this. N peoples are there. So this is n peoples are there. N jobs are there. So this is the n jobs. So one person he must assign to one job. Okay. Another one person he may be assigned to another one job. So that is the concept that is given in the assignment problem. N people to n jobs. So that is n workers. We are just having n jobs. Any worker can be assigned to any job. But one main thing is each we are having cost associated with assigning. So what is that one is we have to minimize the total cost of assignment here. So we can assign so we can assign like this in P1 he may be assigned to job 1, P2 person he may be assigned to job 2, P3 person he may be assigned to job 3, but we have to determine a cost. Okay, so which assignment that gives a minimum cost that will be taken into consideration. That is called as an assignment problem. For doing this assignment problem, I am just going to use given here a concept of how we are just going for assigning. So this one is a cost matrix. So the cost matrix that is normally given here. So the rows it represents the various persons. How many persons are here is 4 persons, and here we are having 4 jobs. If a person is assigned to job 1 means what is the cost here is 9. A person is assigned to job 2 means what is the cost here is that is 2. But we have to assign each and every person to one job. Okay, that is the main goal of this assignment problem. One person he must assign to one job. Next person must be assigned to another one job. We are not able to assign A to job 1 as well as B to job 1. That is not possible. One job it is assigned to one person, another job it is assigned to another one person. In order to find a better solution, what we are just going to do here is actually this assignment problem is nothing but it is a minimization problem. What is this assignment problem? Is nothing but we are just going to have a minimization problem. So since it is a minimization problem, we are just going to use the lower bound here. So what bounding technique bounding function we are using here is a lower bounding function we are just going to use here. How to find the lower bounding function? So state 0 that is the initial one. So for the initial we are not assigning any job. Okay, initial step is we are not assigning any job to any persons. So simply we are just going to find the minimum cost. How to find the minimum cost is I am just going to select the lowest cost in the first row, that is in the person A. This one is the lowest cost. 2 is the lowest cost in the first row. And what is the lowest cost in the second row is, so cost is 6431. Among this one, 3 is the minimum cost. What is the lowest cost in the third row? So what are the costs here? 5818. What is the lowest cost here? 1 is the lowest cost. Next one, what is the lowest cost here? 4 is the lowest cost. Now I am just going to find the bounding function. Bounding function is nothing but 2 plus 3 plus 1 plus 4. That is given here. 2 plus 3 plus 1 plus 4. What is the answer? That is equal to 10. So this is the initial state. So from all the persons, we are just going to select the minimum cost. But that is not the position here. We have to find the optimal solution. That is the best solution we have to take here. Now see here. So we are just taking the first one. Now a person, he may be assigned to job 1. So that is given as A may be assigned to job 1. The first person A may be he is assigned to job 1, or he may be assigned to job 2. The A person, he may be assigned to job 2, and the next one he may be assigned to job 3. Okay, the next person, he may be assigned to job 3. The first person, he may be assigned to job 4. 3 options we are just having here. So I am just giving here A is assigned to 1, A is assigned to 2, A is assigned to 3, and A is assigned to 4. And how to find the lower bound here? So what is here is the first person is assigned to which job? That is the job 1. So what is the cost here is 9. Now in the remaining, we are not able to select this column. Okay, we are not able to select any content from this column. Now our concept is we have to select the remaining values from the remaining columns. B percent. So 431. What is the lowest cost in this one? 437. 3 is the lowest cost. So I am just giving here 9 plus 3. And next one, 8118. What is the lowest cost here? It is having, that is 1. So I am just selecting 1. Next, 694. What is the lowest cost? 4 is considered to be the lowest cost. I am just going to select 4. 9 plus 3 plus 1 plus 4. The answer is equal to 17. So that is given here. Okay, so this is the way of finding the lower bound. And in the next case, so I am just going to content here is the next A equal to 2. Now we are just going to assign the second job to the A person. So what is the cost here? 2 is the cost. The second job is assigned to the next person. Now I am not able to select any content from the second column. So for the second person, I want to select 6, 3, 7. Among this one, which one is minimum? 3 is the minimum one. Next, 5, 1, 8. Which one is minimum? 1 is the minimum. So I am just going to select this one. And next one, 7, 9, 4. Which one is minimum? 4 is the minimum. I am just going to select that one. What is the total cost here? 2 plus 3 plus 1 plus 4. That is equal to 10. That is given here. Okay, so this is the next one. Okay, so next I'm just going to the next one. Now the A person, he is assigned to which job? Means he is assigned to the third job. So what is the third job here? A person, he is assigned to 5. Sorry, A person, he is assigned to the 7. 7 he is assigned. So now we are just going to have here 7. Now I am not able to touch the third row. Third row we are not, third column we are not able to touch here. I want to select the remaining values from the next one. 6, 4, 7. Which one is minimum? 4 is the minimum. And next one, 5, 8, 8. Which one is minimum? 5 is the minimum. So I am just going to select 5. And which one? 7, 6, 4. Which one is minimum? 4 is the minimum. So I am just selecting 4. So what is the total of this one? That is equal to 20. So this is the way of finding the lower bound for the next one. Okay. So now the lower bound for this one, that is equal to 20. Next, A person, he is assigned to job 4. So job 4, the weight is equal to 8. Now I am not able to touch the fourth column. I want to take the remaining values from the next one. B person, he is checking 6, 4, 3. Which one is minimum? 3 is minimum. C person, 5, 8, 1. Which one is minimum? 1 is minimum. D person, 7, 6, 9. Which one is minimum? 6 is minimum. So the total cost here is, that is equal to 18. So we are just having 4 different options now. One, A is assigned to the first job, A is assigned to the second job, A is assigned to the third job, and A is assigned to the fourth job. So bounding function, for the first one it is 17, for the second one it is 10, for the third one it is 20, and for the fourth one it is 18. So among this one, which one is best is, that is, this one is a minimization problem. So we are just going to select the lower bound only. Which one we are just going to select? The lower bound we are just going to select. So the lower bound, which one is minimum, is 10 is considered to be the minimum one. So I am just going to take 10 here and I am just going to explore with that one. Okay. So now A is assigned to the second job. That is not considered as the best solution. Now after this one, we selected the second job. Now B person, he may be assigned to job 1, he may be assigned to job 3, and he may be assigned to job 4. So 1, 3 and 4 is possible. 2 is not possible because 2 is assigned to A person. So now B can be assigned to job 1, B can be assigned to job 3, B can be assigned to job 4. That is given here. How to calculate the lower bound? So we are not able to select any content from this one. That is very important. We are not able to select any content from the second column. Now B is equal to 1. I am just selected which one? 6. Here I am just going to select here 6 as the content. Now we are not going to select this one. Which one is minimum here? 1 is minimum as well as 4 is minimum. 2 plus 6 plus 1 plus 4, that is equal to 13. And next one, job B is assigned to the third job. So third job means which here? 3 is assigned here. Which one is assigned here? 3 is assigned here. I'm just selecting the third one. So 2 plus 3 plus, from the remaining 4, 5 I am just taking here, 4 I am just taking here. What is the lower bound here? That is equal to 14. Next step, B is assigned to the fourth job. Fourth job is, what is the value here? That is equal to 7. I am just assigning 2 plus 7 plus 1 plus 7. Remaining things we have to take here. 1 I want to select here, and for the B, I am just going to select the next one. So 7 can be selected. Okay. So that is the way we are just going to select here. How the values are selected here. So this is the way how we are just going to select the content. Got it. So basically in this one, so we are just going to generate a particular state space tree. So the lower bound here is when B is equal to 1, that is equal to 13. B is equal to 3, that is equal to 14. B is equal to 4, that is equal to 17. So among this one, which one is the minimum one? 13 is the minimum one. So I am just going to select this one. I am not going to select this one, 14 as well as 17, because they are not guaranteed to give the best solution. So going to the next one. After this one, I am just going to explore this one. B equal to 1, I am just going to explore 1. So next possibility, A is assigned to the second job, B is assigned to the third job. Now C can be assigned to third and D can be assigned to 4. Or C can be assigned to 4 or D can be assigned to 3. So how to calculate the lower bound here? So first thing, I am just going to find this one. What is the lower bound for this one? How to find here? What is the value for this one? So A is assigned to the second job. So that is the weight here is 2. So I am just giving here 2 plus, what is the next one? B is assigned to the first job. B is assigned to the first job means what is the value here? That is equal to 6. The value that is nothing but that is equal to 6. And C equal to 3. So C equal to 3 means third person he is assigned to the third job. Third person he is assigned to the third one. So 1 as well as 4. So what is the value here? Total value that is equal to how much? 13 we are just getting here. Going to the next one, the lower bound for this one. B is assigned to A is assigned to the second job, that is equal to 2. B is assigned to the first job, that is equal to 6. C is assigned to the fourth one. C is assigned to the fourth one means that is equal to 8. So this is another one solution, that is 8, and D is assigned to the next one, that is equal to 9. So what is the total cost here? 25 is the total cost, lower bounded. So among 13 and 25, which one is considered as the best solution? 13 is considered as the best solution. So likewise, so this assignment problem is nothing but it is tends to carry out which one is the best solution. Which, so we are having a lot of solutions, we are having a lot of cost. So here we are just going to concentrate on a lower bound because this one is a minimization problem. Now I am just going to find out which solution is considered as the best solution in this one. So this is one of the application of a branch and bound technique. In the next video, I am just going to tell about other applications in the branch and bound technique. Thank you.